Hi, I'm Olivier Levillain. I work at ANSSI, the French Network and Information Security Agency, and I'm going to present to you some work we did on SSL and TLS dataset analysis. So first, just the standard schema to figure to show you what SSL TLS is. You already know that it's a protocol that aims at providing server authentication and optionally client authentication and data confidentiality and integrity. So it's a basic block of internet security today. We are going to look specifically at the first messages of the protocol, that is the client hello, where the client initiates the connection and proposes the different cryptographic features and that it supports. And then the answer of the server, that is the server hello, where the choices are made, which cipher switch we will use, which version, and where the certificate presents itself with certificate chains, with a message that is called certificate and that we will look at afterwards. So there are traditionally three types of methodologies. You either can do a full IPv4 scan, which allows you to see a lot of things. You also can do a scan based on a list of domain names, which allows you to look at the SNI extension and look at virtual hosting. And if you have access to a lot of willing users, you can do passive observation. So in our case, we launched several full IPv4 scans in 2010, 11, and 14. And what's interesting is that with the two first methods, you can choose how you want to stimulate the servers. Okay, so this was about data collection, and now I'm going to talk to you about data analysis, because the motivation for the Concerto toolkit that I'm going to present is that when we first worked on these data, we used Parsifal, a homemade parser generator, so to parse the answers and the certificates, and mostly undocumented and unversioned scripts, which was cool to publish an article. But 3 years later, when I wanted to write my PhD manuscript, I wanted to do some work on more recent data, and so I had some problems with the scripts, but also with criteria which had evolved. Because, for example, the notion of what was a weak suite had a little evolved between 2012 and 2015. So we also wanted to include new external data sets like the one you can get from scans.io. So the way we built Concerto is a way to go back from the raw data and associated metadata like the client hello you used if you get it, and automate all the process. So the process is to prepare the context. The context is injecting the stimulus you used, the client hello you used if you have it, and the trust store, the certificate trust store you want to use to say which host is considered to be trusted, and we used NSS in our examples. Then we have to to inject the answers and to parse them and to extract the certificate, to build to parse the certificate and to build all the possible chains from the certificate messages, and then produce some statistics. Okay, just and to look at the data, it's always interesting to know that SSL TLS data is not always that clean. What you get from a measurement campaign can surprise you. And so if you send a client hello proposing two cipher suites, the blue one and the green one, you expect to get either the blue one, the green one, or an alert, which would mean that the server doesn't understand what you wanted to negotiate. But sometimes you find something else. Sadly, this can be explained. And what's even worse than that the RSA, that the RC4 MD5 is, some servers are willing to negotiate the null cipher suites, which the problem is what does it mean, because it's not specified. We also had a case where our parsers would choke on is a server hello missing 2 bytes. That is, if you look at the message, it's just a good message, but you have 2 missing bytes, which might make you look at your parser and think, is it me or is it the message that's incorrect? So that's why the parsing phase is interesting, and we now are confident that our tool using Parsifal is robust, and the other thing that we find interesting in this phase is to keep the metadata, and in particular the use stimulus, to know which, when you encounter inconsistencies. Okay, so just first simple results about what we can get. So this is about data coming from our campaigns, 2011, 2014, and the other 3 ones, so the full IPv4 from 2015 is from scans.io, and the 2 regarding top Alex and 1 million are also from scans.io. So you can see that TLS 1.2 is getting some attention and is finally being deployed. Just don't forget that it was a specification that was published in 2008. So we could have better results, but at least it's starting to be used. And now I'm going to speak mostly about certificates. So I told you that when the server answers, he presents a certificate message that contains the list of certificates. It should be in order. That is, first the certificate of the server, and then each certificate authority that will sign the previous certificate. In reality, you will find unordered messages. You will find repeated certificates. You will also have useless certificates and sometimes missing certificates, what the EFF called the transvalid chains in their first publication in 2010 or 11. Okay, what's interesting is that TLS 1.3 relaxes this constraint on the order, which is a good thing, because if you look at the quality of certificate chain, you see that less and less chains, certificate messages are in fact RFC compliant, because they are not necessarily ordered for various reasons. So that was just another result concerning certificates. Here is another thing you can get with Concerto. It's an example of certificate message that is not trivial. I will explain first what each stuff is. Gray boxes are what certificates were sent by the server. So the server sent all these certificates, and in particular, this one is the server certificate. And we also have we also consider 3 certificates as trust roots. So these one were we consider them as trust roots. And what Concerto gives you is that it can build a lot of possible certificate chains. So this one is a good one and is essentially the better one you can get. But it's interesting to see that in this case, you have a lot of certificates that have nothing to do with the server certificate. So you can find stuff very diverse in the certificate messages that are sent. To build all the possible certificate chains possible, in fact, it's a little complex to do that, because you have two problems that will lead to combinatorial explosion. The first one is X509 V1 certificates, because as they do not have any extensions, you don't know if they are certificate authorities, and up until recently, they could be considered as certificate authorities. So if you have, let's say, appliances that all generate the same certificate, same subject, same issuer, but they just differ with the public key, you should, in practice, try all the possible combinations if you want to be exhaustive. And in fact, all the signature will fail. Signature checks will fail. So for this reason, we didn't want to look into X509 V1 certificates too much. So we only considered them as certificate authorities when they were in our trust store, which is what browsers do. The other thing is crazy cross-certification. That is, you have a lot of certificate authorities that do cross-certification, and sometimes you have mutual cross-certification, which would lead to cycles, which is not a problem per se. But when you add the fact that some authorities will emit multiple certificates with the same public key, same subject, but with different validity dates, you can have a lot of possibilities to choose from when you want to build all the possible certificate chains. So there was different possibilities, but we chose to limit the number of certificates we took outside of the certificate message when trying to build all the certificate chains. I have still some figures about certificates. I will not speak about all of them, but this one is interesting. It was in the EFF data from 2010. Some server would send you a very, very large certificate message, including all its certificate trust store, apparently. And this is to answer some questions we had on Wednesday about the today's use of MD5 and X509 V1. So I computed some stuff with Concerto yesterday on top Alexa 1 million recent scan from scans.io. So we still have a lot of SHA-1 certificates. We also have several MD5 certificates. And this is interesting also. We have, back from the future, some X509 V4 certificates. Okay, this is about server behavior. In our campaigns, we used multiple stimuli. That is, we probed the same server with different stimuli, which allows us to grasp something into the server behavior, which allows us to look at the intolerance on the full IPv4 space, and also afterwards to look at the SSL-v2 support, which led us to compute a lower bar concerning the drowned vulnerability, because we had 40% of all HTTPS servers in our campaign from 2014 that would answer with the same certificate to SSL-v2 client hello. Okay, this is just a way to say that Concerto is today mostly stupid. It's just a bunch of CSV tables, and the real smart parts are in the parsers and in the way we build the certificate chains. And so we would like to improve some of the stuff, like the backends, more reporting tools, and include all the data sources like certificate transparency, for example. Okay, in conclusion, if we want to analyze SSL-TLS data, we believe that it's important to have good quality data, which I believe we have today, and we can reproduce easily today with the tools at hand. And we should use methodologies to allow for reproducible analysis. And that's where we try to propose something with Concerto. The source code is online in GitHub. There is a little documentation, and don't hesitate to send me a mail if you are interested in this. Thank you for your attention.
We have time for one question. Should be better than 0 questions. Excellent. Oh, now you got a race.
On the SSL-v2 slide, I know there's a lot of clients out there who will send an SSL-v2 formatted client hello, even though they don't support SSL-v2. They actually want to negotiate SSL-v3. The servers here, is the statistic here that they were accepting those formatted SSL-v2 client hellos and negotiating against something better, or were they actually negotiating SSL-v2?
We had two stimuli with SSL-v2. One was just the way to engage a conversation, and which would eventually lead to SSL-v3 or TLS, and one which was pure SSL-v2. And we looked, when I say 40%, that was servers that were accepting to, yes, they were accepting and answering with an SSL-v2 server hello. So we didn't lead the handshake to its end, because we only looked at the first server flight, but yes, it was a real server hello.
All right, fantastic. Why don't we thank Olivier again?